Dear students, today we'll see the second part of the DCET 2019 question paper. So in this, we'll start with the next questions of DCET 2019 question paper. So let's start with the first question, that is question number 21. Circuits which converts irregularly shaped waveform to regular shaped waveform are called as what? Options are Smith trigger, voltage limiter, a comparator, integrator. So from these options, the circuit which can convert irregular shaped waveform, that is any shaped waveform, to a regular shaped, that is pulse or square wave, and that circuit is called as Smith trigger. So Smith trigger, that is option A, is the right answer here. So if you go to see the definition of Smith trigger are also called as squaring circuit because this type of circuit converts irregularly shaped waveform to a square wave or a pulse. Now this can be shown by the waveforms. So here you can see this is the input applied to the Smith trigger, and there are 2 points made, which is called as upper threshold voltage and lower threshold voltage, which are the reference points which are made by the circuit itself. And whenever the input waveform crosses these points, the output will change its state. Now, in that case, we have shown here the input waveform and the upper threshold and lower threshold points. So here you can see this is the input waveform. So this is the input waveform, and these are the threshold voltage. This is the upper threshold voltage, UTP, and this is the lower threshold voltage, LTP, which are formed by the circuit of Smith trigger. And then because of that, whenever there is a crossing or whenever the two inputs meet, one is the threshold points and one is the actual input, they meet at that time, the output will change its state. You can see at this time, the output is going to change its state to minus VSAT. At this time, the output is going to change its state to plus VSAT. Again, at this time, the output is going to change its state to minus VSAT. In that way, the output will be a square wave, or a pulse. So this any input, any irregular shaped input waveform can be converted into a square wave or a pulse at the output by the Smith trigger, where the output is going on changing its state plus from plus voltage saturation to minus voltage saturation. That is the plus saturation voltage to minus saturation voltage. That is negative saturation voltage. So output will be a square wave or pulse. So here you can see the option A is the right answer. That is a Smith trigger. Circuits which converts irregularly shaped waveform to regular shaped waveform are Smith triggers. Then we'll go to question number 22. Oscillator must employ. Options are positive feedback, negative feedback, neither positive nor negative feedback, both positive feedback and negative. So if you remember the idea of an amplifier and its feedback, so whenever we use an amplifier and whenever the amplifier is going to have its input and output, and if the output is given back through a feedback network back to its input, and if that is going to aid the input, if that is going to help the input, then that output will be called as positive feedback. Say for example here, if the phase shift between input and output is 180 degree, and then the feedback is again giving a phase shift of 180 degree, that means the total phase shift will be 360 degree, and therefore it is a positive feedback. That is, the output is going to again be given as the input. From the output, whatever you get will help the input, will aid the input, and that type of feedback will be called as positive feedback. And in that case, the gain will increase and there will be formation of oscillations at the output. So whenever we want to use an amplifier as an oscillator, it should go with positive feedback. And whenever we want to use amplifier as amplifier, then it should go with negative feedback, where the gain can decrease, but it will give us stability to the circuit. So whenever we speak about oscillator, that will be having positive feedback, because only with positive feedback you can generate oscillations. Therefore, option A is the right answer here, positive feedback. So here you can see oscillator must employ positive feedback. Then we'll go to the next question, question number 23. An SCR has dash PN junctions. So if you remember the layer diagram of SCR, you can see that SCR is the four semiconductor layer device. So it is having four semiconductor layers. So you can mark these four layers like this. We can have a P layer, P1, then N1, P2, N2. These are the four semiconductor layers. This point, this terminal will be called as anode, and this terminal will be called as cathode, and this terminal will be called as gate here. So anode, cathode, and gate. This is the structure of SCR. Now in these four layers, when we are having four layers of semiconductor, then we'll be having three junctions. Now here is the first junction. This you can see junction J1. Here is the second junction, junction J2, and here is the third junction, junction J3. So there are three PN junctions in SCR. So there are three PN junction in SCR layer diagram. So the answer should be 3 over here. So B, option B is the right answer, that an SCR has three PN junctions. So here you can see option B is the right answer, that is 3. Then we'll go to the next question, question number 24. A freewheeling diode is used in a controlled rectifier circuit in case of option A, when the load is resistive, option B, when the load is capacitive, option C, when the load is inductive, option D, all types of loads. So here the right answer is option C, that is inductive loads. When the load is inductive, we require a freewheeling diode. That is the stored energy in the inductor whenever the main element like diode or SCR is not working. Okay, now if you are speaking about a controlled rectifier, then we will be speaking about rectifier using SCR. Then in that case, whenever the SCR is not triggered at that time, the uh, energy stored in the inductive load will reverse back and will give a negative voltage at the output. Now that negative voltage at the output should be eliminated by using a freewheeling diode. So a freewheeling diode is used to control, freewheeling a diode is used in a controlled rectifier circuit in case when the load is inductive. So here you can see the circuit diagram. This is the controlled rectifier SCR. So we are having also a half wave rectifier, and this is the freewheeling diode. This is the freewheeling diode, and here you can see we are having a inductive load. So this load is inductive, more inductive. So L is there, so it is inductive load, inductive load. Now when initially when the input is positive half cycle, so this is the input AC supply, positive half cycle and negative half cycle. When the input is positive half cycle, at that time we can fire the SCR between the line, between the angle 0 to 180 degree. So if your positive half cycle is like this, that is from 0 to 180 degree, that is pi. In this you can fire or trigger the SCR at any instant, and you can get this output at the across the load. So across the load you can get the positive half cycle. If you want the complete half cycle, you can get a complete half cycle. If you want lesser than that, if you want a control voltage, you can get a lesser than that, that is the control voltage. But when the input is negative, when the input is negative, that time the SCR is in reverse bias direction. It cannot be triggered. Okay, now there should be no output when the input is negative. So it should be zero. It should be zero. Now what will happen if you don't use the freewheeling diode is, when in the first positive half cycle, when the circuit was working like this, there will be a voltage developed across the inductor, minus plus. Now this voltage, when the SCR becomes off in the negative half cycle, will become a negative voltage and reflect in the output. So in that case, the output can be shown as positive half cycle complete will come, and when the negative half cycle is there, that time a part of negative half cycle is taken and the voltage becomes negative for a small period of time, and then again the next positive half cycle will come at the output. Now in that case, to avoid this, to avoid this, to make the output voltage zero whenever the SCR is not working, so to avoid this, we have to use a freewheeling diode. The energy which is stored in the inductor will be circulated back through this diode. Will be circulated back through this diode. Now, in that case, when the circulation goes, the voltage across the inductor becomes zero, and we'll get a perfect output voltage at the output. That means the output voltage will not go to negative, it becomes zero only. So here you can see the definition. A freewheeling diode placed across the inductive load will provide a path for the release of energy stored in the inductor while the load voltage drops to zero. The freewheeling diode prevents the load voltage from becoming negative. Whenever the load voltage tends to go to negative, the freewheeling diode comes into the play. So here we can have the option C as answer. A freewheeling diode is used in a controlled rectifier circuit in case of inductive loads. So option C is the right answer here, inductive loads. Then we'll go to next question, question number 25. The duty cycle of a chopper is given by. So whenever we have a chopping operation, a chopper is a converter which will convert DC to DC. Okay, so the output will be a variable DC. So you can have this output like this, whose average voltage you can minimize or maximize. Anything you can do, you can increase or decrease the output voltage, the average output voltage. So here, when the output is given, a chopped output is given, you will be having on time. This is called as T on, and this is called as T off. So whenever we speak about duty cycle of a chopper, it will be T on upon T on plus T off. That is the complete time period. So this is the our duty cycle, which can be denoted as alpha. Alpha is equal to T on upon T on plus T off, which is nothing but T on upon the complete time period, because T on plus T off is equal to the complete time period T. So this is the complete time period T. So the ratio for a duty cycle will be the on time period upon the complete time period. So from these options, option B is the right answer, that is T on upon T. So here you can see the duty cycle of a chopper is given by T on upon T, that is on time period upon the complete time period, that is T on plus T off. Then we'll go to the next question. The DC supply of a voltage source inverter, VSI, voltage source inverter, has dash at all the frequencies. Options are high impedance, low impedance, variable, none of this. Now here the DC supply of voltage source inverter. Inverter is basically a circuit which will convert DC to AC. Okay. So inverter is converting DC to AC. So this is called as the inversion operation. Now voltage source inverter, that is VSI, whatever we use, it has negligible impedance at all the frequencies. Negligible means it is very, very low. So here the option B will be the right answer, that is low impedance will be the right answer. The DC supply of a voltage source inverter has low impedance at all the frequencies. So here you can have the definition of voltage source inverter. A VSI is the one in which the internal impedance of the source is negligible. It has a stiff DC source at its input. Therefore, option B will be the right answer, that is low impedance. Then we'll go to the next question. Question number 27. A cycloconverter is. Options are single phase. Option B is three phase. Option C is either of the single phase type or three phase type. Option D is none of this. So a cycloconverter is nothing but a AC to AC converter. It is a AC to AC a converter where the output can have a variable voltage and variable frequency depending upon the firing of the control element like SCR. In this, we can have a single phase cycloconverter also and three phase cycloconverter also. Both types of circuits are available. So here option C will be the right answer. A cycloconverter can be either of single phase type or three phase type. So here you can see option C is the right answer. That is either of the single phase type or three phase type cycloconverter is available. Then we'll go to the next question. Question number 28. Ladder logic programming consists primarily of virtual relay contacts and coils. Option B, logic gate symbols with connecting lines. Option C, function blocks with connecting lines. And option D is text-based code. So in this case, the option A will be the right answer. That is the virtual relay contacts and coils. Because whenever we see the ladder diagram, okay, so the ladder diagram will have relay contacts like normally closed or normally open. This can be normally open, this can be normally closed, and we can have a coil which can give you the output. So here, in this way, each horizontal line which is called as rung is made or is programmed in a ladder logic programming. So ladder logic programming primarily consists of virtual relay contacts and coils. So here the option A will be the right answer. It is virtual relay contacts and coils. So here, if you see the concept of ladder logic is basically a programming language which creates and represents a program with the help of a ladder diagram, which primarily consists of virtual relay contacts and coils. They are based on circuit diagrams and are mostly used in developing programs or software for programmable logic controllers, PLC, used in industrial applications. Then here we see that option A is the right answer. Ladder logic programming consists primarily of virtual relay contacts and coils. Then we'll go to the next question. In a PLC, that is programmable logic control, the scan time refers to the amount of time. The scan time refers to the amount of time in which options are the technician enters the program. Option B, timers and counters are indexed by. Option C, one rung of ladder logic takes to complete. Option D, the entire program takes to execute. So out of these options, the scan time refers to the amount of time in which the entire program takes to execute. That is the option D is the right answer here. Scan time means you are going to refer to the entire programming time, entire execution of program time, that is called as scan time. So here the definition of PLC scan time says that the time taken by the PLC to read the inputs, solve the logic, and write the output is called the PLC scan time. These functions work in a loop. The execution time can vary from 0 milliseconds to 150 milliseconds large and up to 1000 milliseconds. So here you can see a diagram where the first step will be your reading the inputs from the sensors. So reading the inputs and then execute the user defined logic, then write the outputs and then go to the remaining time interval. So this is the steps. These are the steps of scan time. Similar steps can be shown in another way here. So here you can see you can read the inputs from the sensors and then you can execute the program, whatever you have written, whatever ladder logic program you have written, that will be executed. Then according to the that program output, diagnostic and communication takes place, and then you can update the outputs. This is the scan cycle. This is the time required for the complete execution of the program. So here in a PLC, the scan time refers to the amount of time in which the entire program takes to execute. So option D will be the right answer here. Then we'll go to question number 30. 8051 microcontroller has dash byte ROM, that is read-only memory, on chip. So on chip read-only memory. So options are 0 kilobyte, 2 kilobyte, 4 kilobyte, and 8 kilobyte. So if you remember 8051, it has 4 kilobyte, that is 4 KB of on-chip ROM. So it has 4 KB of on-chip ROM. When we studied the features of 8051, this was one of the important feature that it has 4 kilobytes of on-chip ROM. So option C will be the right answer here. So here if you see the concept, program memory, that is ROM, read-only memory of 8051 microcontroller. In 8051 microcontroller, the code or instructions to be executed are stored in the program memory, which is also called as the ROM, that is read-only memory of the microcontroller. The original 8051 microcontroller by Intel has 4 kilobyte of internal ROM. So here you can see the answer is 4 kilobyte. So here option C, that is 4 kilobyte, is the right answer. That is the internal ROM of 8051 microcontroller. Then we'll go to the next question, question number 31. To access internal ROM, to access internal ROM in 8051, pin number 31 of 8051 should be connected to what? To access the ROM memory. Okay, so it is an external access. So to access the ROM memory, pin number 31 should be connected to plus 5 volt. So here you can see option A will be the right answer. That is pin number 31 should be connected to plus 5 volt to access internal ROM. So here you can see pin number 31. EA stands for external access input. It is used to enable or disable external memory interfacing. In 8051, EA is connected to VCC, that is plus 5 volt, as it comes with on-chip ROM to store programs. So if you want to use on-chip ROM to store programs, then EA should be connected to VCC, that is plus 5 volt. For other family members such as 8031 and 8032, in which there is no on-chip ROM, the EA pin is connected to ground. So if you want to use the on-chip ROM which is available in 8051, the EA pin, that is pin number 31, should be connected to VCC, that is plus 5 volt. So here you can see option A will be the right answer. To access internal ROM of 8051, pin number 31 should be connected to plus 5 volt. Then we'll go to the next question, question number 32. When 8051 microcontroller is reset, so when it is reset, so all the registers will get the initial values. The initialization value will be given to every register. Now, in that case, it is asked in this question, when 8051 microcontroller is reset, the content of SP, that is stack pointer, which is going to point the memory location of the stack memory, the stack pointer content will be what? Okay. So when 8051 microcontroller is reset, the stack pointer will have the contains as 07H, and the next location, that is 08H, will be the next accessing point. So the stack pointer at reset will have the or contains of 07H. So here you can see how stacks are accessed. The register used to access the stack memory is known as the stack pointer register. The stack pointer in the 8051 is 8 bits wide, and it can take a value of 00 to FFH. When the 8051 is initialized, that is reset, the stack pointer register contains the value 07H. This means that the RAM location 08H is the first location used for the stack. So here you can see option D will be the right answer, that is 07H. When the 8051 microcontroller is reset, the contents of stack pointer SP, which is going to point the stack memory, will be 07H. Then we'll go to the next question. Push and pop instructions uses which type of addressing mode? Okay, so options are register addressing mode, direct addressing mode, immediate addressing mode, or register indirect addressing. We know that whenever we are going to use push and pop instructions, so the data from the location which we are going to push onto the stack memory, or the data from the stack memory whenever we are going to get back to a location, that location should be represented as a direct number, direct memory. Okay, so it is direct addressing mode which is used for push and pop instructions. So here you can see the a concept, stack and direct addressing mode. A major use of direct addressing mode is the stack. In the 8051 family, only direct addressing mode is allowed for pushing onto the stack. Therefore, an instruction such as push A. Now, whenever you write push A, that is push the accumulator contents onto the stack memory, that will be invalid. You cannot use A. Pushing the accumulator onto the stack must be coded as push 0E0H. Okay, so where 0E0H is the address of a register A. Similarly, pushing R3 of bank 0 is coded as push 03. Direct addressing mode must be used for the pop instruction as well. For example, pop 04 will pop the top of the stack into the R4 of bank 0. So a register R4 will get the data when you use pop 04 instruction. So here you can see push and pop instructions uses direct addressing mode. So option B is the right answer here. Then we'll go to question number 34. Memory type used to access bit addressable internal data memory in 8051C is? So it is the bit data, that is B data, which is used. This type of data type is used whenever we access bit addressable internal data memory in 8051. So here the B data memory type is handled like the data memory type, except that variables declared with B data reside in the bit addressable portion of the internal data memory. So whenever we use B data, that variables will reside in the bit addressable portion of the memory. So a certain portion is declared as bit addressable for 8051. In that memory is used if you use the data type B data. So here you can see memory type used to access bit addressable internal data memory in 8051C is B data. Option C will be the right answer, B data. Then we'll go to the next question, question number 35. Interrupt vector location of external hardware interrupt is. Okay, now in this case, we know that there are two external hardware interrupts for 8051. That is extra hardware interrupt 0 and 1. So INT0 and INT1. Now in this question, the vector location of both the external hardware interrupts is given in the answers. So answer B is for INT0 and answer C is for INT1. So for this question, we are having two answers. That's option B and option C. That is 0003H and 0013H. So here you can see the external interrupt 0, that is the first external interrupt whatever we have. The vector location for that is 0003H, and the next external hardware interrupt what we have, okay, that is having the address as 0013H. So external interrupt INT0 is having 003H and INT1 is having 0013H. So both these options are there in the answers. So both we can mark as the addresses 003H and 0013H. So here you can see option B and C both are marked because option B is for INT0, that is the first external hardware interrupt, and option C is 0013H, that is the vector location for the second external interrupt option vector location. Then we'll go to the next question, question number 36. In 8051 for serial data transfer, timer mode is used. Okay, so here in 8051 for serial data transfer, timer mode is used. So in this case, we are going to use timer 1, which can be programmed with a 8-bit data, and with that data you can fix the uh, mode in auto reload. Okay, so here you can see that baud rate is selected by timer 1, and when timer 1 is used to set the baud rate, it must be programmed into mode 2, that is 8-bit auto reload mode. So that we have studied when we studied the serial communication, serial data transfer in 8051. So in this case, the option will be timer 1 in mode 2. So that is a programmed mode in which 8-bit number you can put for the time, and that can be automatically reloaded. So here you can see that option D is the right answer, timer 1 in mode 2. In 8051 for serial data transfer, timer mode uses timer 1 in mode 2, in the second mode. Then we'll go to question number 37. Superposition theorem can be applied to a linear bilateral network having. Options are only one source, more than one source, no voltage source, no current source. Obviously, superposition theorem is going to be applied to a circuit which have more than one source. So option B will be the right answer here. And more than one source only we are going to use, and then with individual sources we are going to take the summation effect of the circuit. So here you can see superposition theorem states that in any linear active bilateral network having more than one source, the response across any element is the sum of responses obtained from each source are considered separately, and all other sources are replaced by the internal resistance. The superposition theorem is used to solve the network where two or more sources are present and connected. So here option B will be the right answer, more than one source. Superposition theorem can be applied to a linear bilateral network having more than one. Then we'll go to question number 38. When the load resistance is equal to the Thevenin resistance, that is, when it is equal to the equivalent of Thevenin resistance of a network, then dash is transferred from dashes are transferred to the load from source. So from source to load, what is transferred is maximum power. Maximum power is transferred when the load resistance is equal to the Thevenin resistance. So option A will be the right answer here, maximum power. And this is stated in our maximum power theorem. So here you can see maximum power transfer theorem. Maximum power transfer theorem states that a resistive load being connected to a DC network receives maximum power when the load resistance is equal to the internal resistance known as Thevenin's equivalent resistance of the source network as seen from the load terminals. So here option A will be the right answer. That is maximum power will be transferred to the load from source. Then we'll go to the next question. Question number 39. Series resonance has the following condition. XL is equal to XC, RL is equal to R0, Z1 is equal to R2, XL is greater than XC. Now in this case, if you see the series resonance circuit, so in series or resonance circuit, we can have a resistor, we can have a capacitor, we can have a inductor. Now this all will be connected with a AC source, and this will be called as series resonance. So this is the voltage and this is the current which is going to flow. Now this R, C and L, all these elements will provide their own opposition to the flow of current. So opposition provided by the resistance is given as R resistance. Opposition provided by the capacitance is given as CXC, and opposition provided by the inductor is given as XL, where XC and XL are the reactances, which is the opposition to the flow of current. Now this circuit will have minimum opposition to the flow of current. That is, the series resonance condition will occur when the opposition by the capacitor is equal to the opposition by the inductor. That is, the reactance of the capacitor Xc is equal to reactance of the inductor XL. So when both these reactances are equal and opposite, they cancel out each other, and what remains is only resistance in the circuit, and therefore it will be a minimum resistance, and we can have a graph of the maximum current at the point of frequency where both these reactances get cancelled. So this can be your current is maximum at this resonant frequency. This is frequency, and this is where your series resonance condition takes place. So because the reactance of capacitor should be equal to the reactance of inductor, here the option A will be the right answer. That is XL is equal to XC. That is option A is the right answer here. So XL is equal to XC is the condition when series resonance is occurring. Then we'll go to the next question, question of 40. Bandwidth endpoints on a series resonance curve are called as what? So whenever we have a curve like this, whenever we have a curve like this, okay, and then say for example, this is your current or voltage. So this is current and this is frequency. Okay, so this will be the maximum point. This is the maximum current point, that is Im. And then we have to come down to 70.7% of the maximum, 70.7% of maximum, that is Im. And then from these 2 points, whatever frequency we'll get, this is F1 and this is F2. This will be called as your bandwidth. This will be called as bandwidth. Okay. Now, these points of 70.7% in case of voltage or current. So whenever voltage is taken as 70.7% or current is taken as 70.7% of the maximum, these points are your minus 3 decibel points, which can also be called as half power points. The power becomes half at this level here, where you take 70.7% of the maximum voltage or current. So power becomes half. So those points are also called as half power points. So option B is the right answer here. Bandwidth endpoints on a series resonance curve are called as half power points. So here you can see option B, that is half power points, is the right answer. Thank you, students.